Good evening, everybody, and it's really wonderful to be here. First of all, it's a real treat to be associated with the Leakey Foundation that has done so much to make paleoanthropology the interesting place that it is over the last several decades now. It's a really unique organization. And it's also wonderful to be here in this new facility of the California Academy. I had not had a chance to visit the new building yet, and we had a little tour this morning, and it was absolutely fabulous. I'm very, very impressed indeed. So I'm very happy to be here tonight. And what we're here to talk about is this strange little creature, the Hobbit, which I think it's safe to say is one of the most extraordinary finds that's ever been made in the entire century-and-a-half history of paleoanthropology. And I suppose that it's my role here tonight to represent the average paleoanthropologist. And that is to say, a person who, without actually having seen the original fossils, is still totally mystified by the strange bones that have been called Homo floresiensis. These bones have already taken quite a long time for the profession of paleoanthropology to digest, and some 7 years after they were initially announced, the period of digestion really isn't over. So I think what we can think of tonight as being is a kind of a progress report. And I suppose I should really start by explaining why I'm so puzzled and mystified by these bones. Well, to begin right at the beginning, in 2004, a joint Australian-Indonesian archaeological team reported a very bizarre finding at the cave site of Liang Bua that we see here in the western part of the Indonesian island of Flores. Now, Flores is a sort of a medium-sized island that's situated about halfway along the Indonesian island chain, as you see here. But it does lie beyond what is known as Wallace's line, which you also see. It's the left-hand line on this map here. And this line basically demarcates two biogeographically distinct parts of the Indonesian archipelago. To its west is the part that's connected to the Asian landmass at times of low sea levels, and to the east of it are the islands that remain isolated from the Asian mainland when sea levels drop. And the point here is that Flores, as you can see, is a true island in the sense that it's isolated, has been isolated from the Asian mainland for a very, very long time indeed. Now, ancient stone tools like the ones that you see in this slide had already been unexpectedly found in the eastern part, in the Sewer Basin at the eastern end of Flores, when work began at Liang Bua in the early 2000s. And some of these tools are dated at as much as 880,000 years ago. But when they were discovered initially, it was unknown exactly who had made these quite simple stone tools, or how the people who had made them had gotten to the island. People guessed that they might have been the work of Homo erectus. And as I'm sure you all know, Homo erectus is a well-known extinct human relative that flourished in Eastern Asia from 1.5 million years ago or more to maybe as little as 40,000 years ago. Its fossils are well known, particularly from Java and China, and this particular one we see here comes from Java. So you can imagine the surprise when the hominid fossils that soon turned up at Liang Bua Cave looked like the very antithesis of Homo erectus. And you can easily see that in this comparison with a Homo erectus composite reconstruction skull on the left and the Liang Bua hominid on the right. By the way, this illustration is not to scale, and Homo erectus is in fact a lot larger than the little diminutive individual from Liang Bua. Now, excavating close to the entrance of the cave at Liang Bua in the year 2003, the archaeologists uncovered the remains of at least 6 and possibly as many as 12 hominid individuals of this new kind. And while most of the handful of fossil individuals known from Liang-Boa were represented only by single bones or teeth or just a few pieces. Among them was a pretty complete skeleton that received the rather unimaginative identifier of LB1, which is probably one reason why the informal moniker of the Hobbit caught on so quickly. But LB1 itself was amazing. It was absolutely unlike anything anybody had ever seen before, and nobody could have imagined this thing. Now, in life, this tiny individual, now thought to have been a female, had stood not much more than 3 feet tall, and here she is in reconstruction compared with a modern woman. And what's more, the skull of this individual had contained a brain that was no bigger than that of a chimpanzee, which to say it was only about a third of the size of our own brains. And on the left here, oh, I'm sorry, we've gone too far. There we go. On the left here is an electronically produced image of the inside of LB1's brain case, which is basically what we can take to the external appearance of the brain itself was. And it's compared with a brain cast of Homo erectus that's seen on the right here. And you can see there's an enormous size difference. The Homo erectus brain is well over twice the size of the Hobbit's, even though it's still not much more than half the size of ours. Now, the particular combination of features that we see in LB1 might not have been as surprising as they are if the Hobbit had been discovered at, for example, a 3-million-year-old site in Africa. Because after all, that long time ago, 3 million years ago, all hominids were African. All of them were small-bodied, and all had very archaic limb proportions and small brains, which happens to be a good general description of the Hobbit as well. And here's a fabulous reconstruction of LB1 by the paleoartist Elisabeth Danes, which shows all of those general features that I just described. But of course, in the time that's passed since 3 million years ago, there's been a huge amount of evolutionary water under the hominid bridge, as it were. And all hominids from later times that we knew of departed hugely from the ancient African template. So imagine how amazing it was when dating of the deposits at Liang-Boa showed that these strange hominids had lived there incredibly recently. The oldest Hobbit bones found at the cave were well under 100,000 years old, and the youngest of them were a mere 17,000 years old. And the LB1 skeleton itself was that of an individual who had lived just 18,000 years ago, which was well after both Homo erectus had become extinct in Asia and Homo neanderthalensis had become extinct in Europe. So looking at the bones or Elizabeth's reconstruction of the living creature, you'd never have guessed that this peculiar individual had lived such a short time ago. So how do we explain this anomaly of time versus morphology, time versus anatomy? Well, broadly, 3 possible explanations have suggested themselves to the people who've participated in what has been an increasingly vocal debate about what these odd fossils represent. And the first of these possible explanations is the one that was initially favored by the scientists who, in 2004, made LB1 the type specimen of the new species Homo floresiensis. They thought this tiny form was most likely a descendant of a Homo erectus population that had somehow made it across the water barrier to Flores at some remote point in time, and that had eventually become dwarfed, that is to say, reduced in body size as time passed. Now, at least in principle, this was a perfectly reasonable speculation, given the fact that dwarfing of species that have been isolated on islands is a well-documented phenomenon in paleontology. It happens quite frequently. And indeed, in the very same Liang-Boa deposits that had yielded LB1, the remains are known of an archaic elephant relative that you see in this slide. And that's a pygmy elephant tooth in the middle there, and compared to another elephant tooth, a full-size elephant tooth, also from the site on the far right of the slide. And here is an artist's size comparison of the actual animals represented by these teeth. And as you can see, the size difference, if not the shape difference, is quite similar to what we saw reconstructed in the comparison of LB1 and the modern female that I showed you a few moments ago. There's a regular size elephant, and then this Asian elephant, the stegodon, in light color in the front there. But dwarfism's opposite, that is to say, a giantism, is also a common phenomenon on islands, including on Flores, as this slide also shows, with the Komodo dragon, the world's largest lizard, that we see on the right-hand side of the slide. And while they're today found only on the nearby island of Komodo, these fearsome beasts were common in Flores in the Hobbit's time. And quite frankly, it beats me why any hominid would want to become dwarfed on an island crawling with such supremely nasty creatures. But even more important, although nobody knows just what a dwarfed Homo erectus would actually have looked like, to me, LB1 just simply doesn't look the part. And I know Bob has strong ideas about this too, which he'll talk to you about. And there just isn't much that you can point to in the morphology, in the anatomy of LB1 to connect it specifically with Homo erectus. So what about other possibilities? Well, a second one that's been favored by a large contingent of researchers is that the curious morphology of LB1 is due to some kind of pathological condition. And we see here, courtesy of Bob, a modern victim of such a developmental defect. These are two views of the skull of a microcephalic, that is to say, an individual in whom the brain had simply not expanded as he grew. And although this condition is fairly rare in modern populations, microcephaly from a number of different causes is well documented in Homo sapiens. Now, this notion of pathology is actually a theme that has often been raised historically to explain unexpected morphologies among newly found hominids, fossil hominids. And indeed, such arguments go right back to the time of the discovery of the very first Neanderthal in the mid-19th century. And it certainly is true that a whole host of pathological conditions have actually been identified in various individual fossils. It's not that rare for you to come across a fossil that has a pathology of some kind in its bony structure. But they all look like their equivalents in modern population. And the Hobbit is like nothing that you have ever seen. So while it's true that there are many different developmental disorders and disease states that can lead to reduced stature and reduced brain size in members of our species, and I'm sure this would have been true for Homo erectus as well, I'm very dubious about this as an explanation for the Hobbit's bizarre morphology. For a start, the structure of Homo floresiensis does not mimic the spectrum of features that's shown by any pathological condition that I know about. And it's worth noting also that microscopically, the bone of LB1 is said not to show any signs of abnormal development, as you might expect to find in a diseased condition. What's more, although LB1 gives us the only Hobbit cranium that we actually have, there's a quite well-preserved lower jaw of a second individual, known as LB6, equally imaginatively, that has the same basic features, and you see this one here. Now, having two individuals with the same basic morphology makes it rather unlikely that LB1 was individually pathological. And it also strongly suggests, I think, that whatever their origin, LB1's morphological oddities were features of the entire population that she belonged to. And it's highly implausible that a whole population would mimic a disease condition, even if we could show, which I don't think we can, that any condition actually exists that would explain the curious morphology of LB1. So, if we can also rule out pathology, we're left with just the third possibility, which is the one that I personally favor. And that possibility is that Homo floresiensis is the descendant of a very ancient lineage indeed. Let's look again at the extraordinary anatomy of LB1. Now, you put all the features of LB1 together, and they are totally unique. It's unique and completely out in left field compared to anything else we know in the hominid record. But many of the individual features of LB1 are actually pretty instructive, I think. For a start, let's take a look at LB1's unfortunately rather fragmentary pelvis that's seen above in this comparison with a modern human female in the row below. And you can see that LB1's iliac blade, this big lump of bone at the top, is quite broadly flaring, contrasting with our own more narrowly constricted pelvis. And while it's quite likely, actually, that a broad pelvis was primitive for the whole genus Homo, overall in this structure, the pelvis of LB1 seems more reminiscent of the early bipeds. Forms like the 3.2 million year old Ethiopian fossil Lucy that we see here, who of course is the most famous member of the ancient species Australopithecus afarensis. And this primitiveness is, if anything, even more true of LB1's legs, which are rather short, as we see here. And those legs also, by the way, show a rather Australopithecus-like form of the way in which the femur articulates with the pelvis. A small femoral head is supported by a relatively long femoral neck. And LB1's feet, seen in this absolutely dreadful photo we see here, are odd as well. Although LB1 had a big toe that, like our own big toe, was in line with the others, it was a pretty short toe. And the whole structure of the foot with a relatively elongated front part suggests a form of toe-off during walking and a kind of gait during walking that was very different from our own. Moreover, the foot itself was unbelievably long, especially when you compare it to the rather short limb elements. And here you see it compared to the femur and to the tibia, the lower leg bone, an incredibly long foot. And again, this is a strong resemblance to the early bipeds, and even actually a resemblance to apes. Above the waist, the arms were also long, rather than shortened like those of typical members of the genus Homo. And indeed, LB1's ratio of humerus, upper arm bone, to femur, upper leg bone, length is matched in comparable skeletons only by Lucy herself, the very Lucy-like proportions of these bones. And it's also been inferred that LB1 actually had proportions of the rib cage that were unlike ours and that more closely matched those of early bipeds like Lucy. Well, continuing this list of archaic features, the bones of the hobbit's wrist are strikingly primitive and share some very close similarities with apes and ancient bipeds. And LB1's finger bones have strong ridges for the attachment of the flexor muscles, suggesting the kind of very powerful grip that climbers need, habitual climbers need. So altogether, in its body skeleton, the Flores hominid shows a remarkable combination, a mosaic of unique features, along with an apparent conservation of many general characteristics that would have been useful, or had been useful certainly, to early hominids for tree climbing. And at the same time, while there is a lot about the body skeleton of LB1 that's unique, there is nothing much, as I've said, to connect the Flores hominid specifically with us, or indeed with Homo erectus. And then, of course, there's the skull, which is like nothing else that we know of. It's certainly fundamentally, let's see, that's much better. It's certainly fundamentally unlike ours, as this comparison shows. Homo floresiensis on the left, the modern Homo sapiens on the right. And you can see a fundamental difference in skull structure. About the only thing that they have in common is a large degree of reduction of the face, very small faces in both cases. And what's more, apart from the small size of the brain case, the hobbit skull actually doesn't look much like any Australopith either. One possible exception is in the bony struts and pillars, or so-called pillars that you can see on either side of the nasal opening. of the Flores skull in this view, but I think it would be unwise to put too much emphasis on this, and the overall skull proportions are clearly not Australopith-like. They're clearly not like those of the early bipeds. Early bipeds, tiny brain cases, very big faces, and in the case of Flores, tiny brain, but a very small facial skeleton as well. Still, there is that small brain, which is very unlikely to have been scaled down from a brain of Homo erectus size, as I think Bob will explain. And to me, at least, as to many other people, the simplest explanation for the small brain is that, in contrast to what was going on in other lineages of Homo, neither the brain nor the body had ever been big in the lineage from which LB1 sprang. Now, currently, the earliest hominids known outside Africa are fossils that were found at a place called Dmanisi in the Caucasus, in the Republic of Georgia, between the Black and Caspian Seas. And we see one of them here. It's 1.8 million years old, and again, it is very different from the Hobbit. Now, these Dmanisi specimens are sometimes assigned to their own species, Homo georgicus, and we have pretty good fossil evidence that they were rather small-brained. They were also quite small-bodied, although they were both taller and bigger-brained than LB1. And they made only very primitive stone tools. Now, these Dmanisi hominids were discovered at a time when hominids were believed to have exited Africa for the first time pretty late, maybe only 1 million years ago. And their amazingly early date of 1.8 million years came as to paleoanthropologists as much of a surprise as did the recency of the hobbits later on. But the Dmanisi hominids did and do demonstrate that very early exits from Africa of hominids that were both anatomically and technologically primitive were indeed possible. And this, of course, invites speculation that the Flores hominids might be the descendants of an even earlier hominid exodus from Africa that as yet we know nothing else about. And if this is actually the case, it would go a very long way, I think, towards explaining the combination of tiny brain and body size in LB1. And it would also explain why the Hobbit displays so many archaic features alongside unique characteristics that were evidently acquired later over the course of a long, independent, isolated evolutionary history. And if this is right, it upends what we thought we knew about the early evolution and spread of the hominid family, and it means that we're going to have to look again at the very early roots of our own lineage. And it also, by the way, may suggest that we're deluding ourselves when we assign floresiensis to our own genus Homo. Now, all in all, this is a pretty amazing scenario that's presented to us by the Hobbit, one way or the other, and substantiating it at any level of certainty is going to depend on the discovery of new fossils that have yet to be made. But who in the year 2000 would ever have predicted that something as peculiar as the Hobbit would ever be found? And quite honestly, nobody would. Anyway, I hope I've been able to give you some idea why I and many others are still so mystified and intrigued by this extraordinary hominid of Flores. And now it's time, I think, to turn the stage over to Bob, who has some very definite ideas of his own.
As Ian pointed out, the Hobbit comes from the island of Flores, which is the fourth island east. If you start traveling from Java, then you eventually come to Flores. And it's separated by a deep sea channel. And on that island, there is the spectacular find that he talked about. And Lingbois is actually the name of the cave where the Hobbit specimens were found. Lingbois, imaginatively in the local language, means cold cave. And all of the fossils there have been called LB something or other, and the main specimen is LB1. In my lab, we call it LB1 Kenobi. And the spectacular thing about LB1 is that it's tiny. As you can see from the limb bones on an Indonesian banknote, It's about the same size as a dollar bill. And so you can see really just how tiny that individual was, about 3 feet high. And so it's really a very striking individual. And you can see the skull is very small. This is the most important slide that I will show, which is all of the data that I could collect on the size of the brain throughout the fossil history of hominids, going back to 3.5 million years on the left. And so as you go from left to right, you can see that there is a gradually increasing rate of change of brain size. And so brains simply get bigger all the time throughout the fossil record that we have. Now, Ian is a specialist on the fossil record for hominid evolution in general. My speciality is in the evolution of the brain. I've been working on that for 40 years as one of my main research interests. And in fact, in 1982, Ian invited me very kindly to give the James Arthur lecture on the evolution of the human brain. I was very proud of this. I told a colleague at University College London that I was going to New York to give the 52nd James Arthur lecture. And she said, "That sounds like an incredibly short lecture to me." But all of this is to establish my credentials as an expert on the brain, and that is the thing that really struck me about the Hobbit. As Ian said, the primary skeleton, LB1, is 18,000 years old, and this is where it appears on the graph, on the far right. It is way off the curve, and it is the only hominid we know that falls that far away from the curve. That is my starting point. That brain size is really, really weird. And so we need some kind of special explanation as to why a hominid that is only 18,000 years old has such a tiny brain compared to every other hominid we know. And so this is where I should be going. Now, the discoverers produced this explanation, as Ian said. If you look at the top left, the people who actually describe the Hobbit in nature pointed out that they thought that it was a dwarf form of Homo erectus. And so body size had decreased because it was an island living form. So their explanation, the red dot up there, is floresiensis, and it is a descendant of Homo erectus. Now, as Ian pointed out, there are other possibilities that people have discussed. If you look at the bottom right, there is Homo georgicus, and this is the 1.8 million year old hominid that was discovered in Tunisia in Georgia, not Georgia, Atlanta, but Georgia in Central Asia. And that has been quite significant in some of the discussions, and in fact, Ian mentioned this as one possible way of explaining the Hobbit. And the other possibility is to go back even further and say that the best way we can explain that tiny brain is to say that the Hobbit diverged so early that all hominids had tiny brains at that time, and while everybody else was growing bigger brains, the Hobbit didn't bother. Now, one thing about this that I will really like to emphasize is that we only know the brain size for LB1. Now, various people have carelessly talked about a population of small-brained hominids. We have one small-brained hominid. We have fragments of 8 other individuals, and the biggest fragment is that second lower jaw. Now, what we can say pretty certainly from the other fragments is that they were probably all quite small in their bodies. We cannot say anything at all about their brain sizes. So what we're trying to do is to explain the tiny brain size in one individual, LB1. Now, as I've said, several authors have tried to derive the Hobbit from the Tunisia hominids. With one of the skulls is shown up there, we actually have 5 skulls of the Dmanisi hominid. And if you look on the right, there is the Hobbit again. And the Dmanisi hominids, on average, have a cranial capacity, a brain size of 650 cubic centimeters. In the Hobbit, it is 400 cubic centimeters. So Dmanisi already had a brain size more than 50% bigger than in the Hobbit. But if we put the brain sizes for 4 of those skulls onto that curve, they come out there in the middle. They are precisely where you would expect them to be 1.8 million years ago. And the problem with the Hobbit, it is not where you would expect it to be 18,000 years ago. I don't think Dmanisi explains anything about the small brain size of the Hobbit. Now, the authors of the original paper in Nature came up with the explanation that living on islands had reduced the body size, and that the Hobbit has a small brain. The LB1 skeleton has a small brain because it's only 3 feet high. Now, in fact, that's one of the things that I had done an awful lot of research on, is the size of the brain in relation to body size. And one of the neatest examples we have, which illustrates what happens in all mammals, is that within a species, brain size doesn't change very much if you change body size. If you look on the left, we have bred dogs so that the biggest dog is 20 times as heavy as the smallest dog. And there is, in fact, a wonderful display on the ground floor of the California Academy that has skulls of different breeds of dogs. And you can see precisely my point. If you look on the right, you can see the skulls vary tremendously in size, but the brain case doesn't. The brain case increases mildly with body size, but it's nothing like the increase in overall size. And so if we take 30 breeds of dogs and plot brain size against body size, we get that curve there. So a straight line with logarithmic plot. And that line has a very flat slope, and what that tells us is that brain size increases with body size, but at a very slow rate. In fact, I've done this kind of analysis for primates. Within primate species, the brain increases even less with body size. But if we take the dog case for the sake of argument, which agrees with a lot of mammal studies, and you work out how big the Hobbit would have to be to have a 400 cubic centimeter brain if it were derived from Homo erectus, the answer is it would have to be 1 foot high. Now, the Hobbit is admittedly small, but it's not 1 foot high. It's 3 feet high. And so simply reducing the body size does not explain that tiny brain size. So the fact that the other fossils that we have from Flores are small doesn't help us explain that brain. I don't care if the whole population were 3 foot high. The brain size doesn't fit that body size for any known hominid. Now, one other study, it's been kind of field day for people to come out of the woodwork and publish papers about small brains in chosen mammals. Most of the time, they've never worked on brains before. And this is a wonderful example from Nature about hippopotamuses. And both Ian and I have done work in Madagascar. And one of the neat things on Madagascar is they have 3 different species of small-bodied hippopotamus. And this is always quoted as an example of island dwarfism. But in fact, if you look in Africa, the smallest hippopotamus, smaller than the Madagascar ones, is the Liberian pygmy hippopotamus. And all we know is that the hippopotamuses on Madagascar are medium size. We don't know that they're dwarfs because we don't know how big the ancestor was. It's quite possible that the hippopotamus we know and love from Africa is actually an enlarged, a gigantic form that evolved from Africa. From an African stock, and that the common ancestor of hippopotamuses was actually quite small. And so to call them dwarf forms is actually already an overinterpretation. Anyway, on the top right, you can see a skull of a modern hippopotamus. And the middle right, you can see one of these Madagascar hippopotamus. They're subfossils. They're a few thousand years old, and it's smaller. And in the paper in Nature, there was this plot of brain size against skull size. The common hippopotamus is the one at the top, the green dots. There are two of these subfossil forms in Madagascar. And then C. floresiensis is the pygmy hippopotamus. And if you look at that graph, it gives you a strong visual impression that the modern hippopotamus has a relatively bigger brain than the two subfossils. And the paper explained this as an effect of dwarfism, that because these hippopotamuses were isolated on Madagascar, their brains got smaller, and that would explain the Hobbit. In the title of the paper, it says Homo floresiensis. And one of the reasons I like to engage in lectures and debates is because people ask questions or make observations about things I've totally missed. And I was involved in a debate in Boston University last year, and Matt Cartmill said, "Isn't that strange, those green dots there, they curve. If you look at it, it's a curve. It isn't a straight line like the others." And I said, "You're right." So I went back and checked the paper. And in the supplementary evidence for the paper, it points out that most of those hippopotamuses, or many of them, are subadults or juveniles. Now, everybody knows that if you're going to compare brain size, you need to take adults. So the brain is strange. It reaches its adult size very early. So if you take an immature individual, its brain will be oversized. So all we did was to take out all of the young individuals, and this is what you get. There's no difference in relative brain size between the typical African hippopotamus and the Madagascar forms, nothing that you can demonstrate statistically. I wonder what the reviewers of that paper were doing, letting a paper through that has a graph which includes immature individuals. Now, the other problem about this is everybody is treating islands as if they were all the same. And Madagascar is a huge island. It's been called a small continent instead. It's 10 times as big as Java. Sorry, it's 4 times as big as Java. And Java is 10 times as big as Flores. And people are writing as if it doesn't matter how big the island is as long as it's an island. Okay, now I was born on a small island and I do not have a small brain. And the thing is, in Java, the latest surviving Homo erectus, which is between 50 and 150,000 years old, is on Java in Gandong. And if the Hobbit were derived from an erectus, that would be the obvious place to look. It's just 4 islands across. And the Ngandong Homo erectus from Java have the biggest brains we know from Homo erectus. And so it would have been a major job to reduce that brain size to produce the Hobbit. Now, I've recently put 2 students on different projects to look at brain size in primates in that very same region, comparing primates living on the mainland with primates living on islands. And there are 2 primates that are pretty widespread. One of them are macaques, and the other are gibbons. And I've only produced a plot there of the gibbons. If you plot brain size against body size, the island forms are in blue, and the red forms are the mainland forms. They overlap completely. Island-living gibbons do not have smaller brains than mainland-living gibbons. So there's nothing magical about islands as far as primate brains are concerned. And the macaques at the top, you get exactly the same result. There is no decline in brain size for primates that live on islands in that very same Southeast Asian region where the Hobbit was found. Now Ian has shown this skeleton, and he's pointed out already, if you look at the bottom, the foot is about 2/3 as long as the lower leg. Just have a look at your foot and imagine that it were 2/3 as long as your lower leg. This is truly weird. And even Australopithecus does not have weird feet like that. But the interesting thing is various studies have been done on parts of the postcranial skeleton. Has been done on the foot, been done on the lower limb bands, on the wrist. And all of them indicate that the skeleton looks more like a chimpanzee than like a human. It's closer in its anatomy to a chimpanzee. And that is truly weird as well. And so I think it's rather difficult to explain this away as some kind of late surviving Australopithecus. One of the studies is on the wristbands, and if you look at the bottom right, there are 3 different wristbands. The first column on the left is the chimpanzee, the middle column is the hobbit, and on the right are modern human. And you can see how surprisingly similar those wristbands are between the hobbit and the chimpanzee. And there is not much resemblance to any hominid. And this, I think, is seriously worrying. Now, one of the things that many people have said in these studies on the individual parts of the skeleton is that you cannot explain the strange features through pathology. That statement is scientifically indefensible. There's a very simple reason. I have been through the museum collections of the world, and I found over 100 skulls of modern humans suffering pathologies of the brain. I have not yet found a single skeleton. And so there is no scientific evidence from the museum collections. We simply don't know what the rest of the skeleton looks like in pathological humans with small brains. So this is a major gap in our knowledge. What we do know is from the medical literature that the genes that affect the brain also affect the rest of the skeleton, as you might expect. Now, Ian mentioned the tools, and in fact, the tools are a bit of a problem. The first problem is if you've got a chimpanzee-like wrist, how do you make stone tools? But the second thing is that, contrary to what Ian believes, I think these tools are pretty sophisticated, at least some of them are. And I have a colleague at the Field Museum, Jim Phillips, and we go off to the pub every now and then. And when this Nature paper came out in 2004, I took one look at the brain size and said, no. And then I looked at the tools, and I'm not an expert, but I took that picture on the left from the 2004 Nature paper along to the pub, shoved it across to Jim and said, who made those tools, Jim? Oh, Homo sapiens. And the reason he said that is because the technique that's been used for some of those tools is the prepared core technique. This is a huge breakthrough in industrial technology that occurred, as far as we know, in the common ancestor of Neanderthals and modern humans, where instead of turning one piece of flint into a tool, you prepare a core, and the flakes that you strike off from the core are the tools. And this vastly increases the amount of cutting edge you can get from a piece of flint. And if you look at this tool on the right, which was found along with the Hobbit, you can see the scars on the top surface where flakes have been removed to prepare the core. You can see the flat surface on the underside, and you can see the striking platform where that tool was hit, where the core was hit to break off the blade. And fine blades, known as bladelets, are unique. Humans, even Neanderthals, did not make bladelets, and there are bladelets in that tool assemblage. And so there is a huge enigma with those tools. I don't think we can explain those tools easily. Now, the final point I want to make with respect to the region, you may not be able to see the figures. It doesn't matter. This is a colleague of mine, John Terrell, He went through all of the literature to find the earliest secure dates for archaeological sites for Homo sapiens in Asia, Southeast Asia, and Australasia. And you needn't read those figures because they're all 45, more or less. Now, what this tells us is that as soon as humans got into Asia, they went through like a dose of salt, somewhere in Australia within a very short space of time. There are two ways to get through Australia. There's a northern route and a southern route. The southern route is through Flores, and I cannot believe that Homo sapiens did not go through Flores 45,000 years ago, as it did everywhere else. Now, the explanation has been suggested is microcephaly. That picture is of Toiku Jakob, who unfortunately died a few years ago, but Toiku Jakob was the doyen of paleontologists in Indonesia, and he immediately said, when the Flores hominid was described, this is not a new hominid species, it is a modern human suffering from microcephaly. Microcephaly simply means small head. There are 400 different genes that can produce this condition, but the average brain size in a modern human microcephalic is 400 cc's, just as it is in the Hobbit. And that is a comparison between the Hobbit skull and a modern human microcephalic to scale. And so the brain size is the same and the skulls look reasonably similar. Now, the final point I want to make about the microcephaly hypothesis is that Ralph Holloway, when we first talked to him, he in fact was in a film that BBC Horizon made with us about the Hobbit. And he at that time was sitting on the fence and said he thought that the Hobbit was a new species. And he and his colleagues have just published a paper in the Proceedings of the National Academy of Sciences. If you look at that bottom graph, they've done intensive studies on modern human skulls in the green area and modern humans suffering from microcephaly in the red area, and the Hobbit with different measures essentially falls within the zone of the microcephalics. Now, microcephaly, as I've said, can be caused by 400 different genes. The most obvious effect is that the brain size is tiny, but the body size is usually undersized as well. And there are dental anomalies in most of the specimens that you look at. And the LB1 specimen, if you look at the upper jaw and the top, the second premolar tooth has been rotated through 90 degrees. This was listed as a feature of the species. It is a pathology. And in the lower jaw, two of the teeth are congenitally absent, where you can see the red arrows. So the type specimen of LB1 has dental anomalies, okay? So I really want to emphasize there's a two-step procedure here. One is that I'm seriously worried about the brain size, and I don't think anybody has come up with a convincing explanation for why an 18,000-year-old hominid on Flores would have a brain that small if it were normal. The second point is that one possible explanation is that this is due to microcephaly. But I'm not wedded to that explanation. If somebody can come up with a better one, I'll happily accept it. I just think that that tiny brain size is weird. And I think we have all been misled by this term Hobbit that was applied, and this is probably the reason why so many people enthusiastically welcomed this apparent new hominid species, because of the Hobbit films. And I was misled by this too, until one day I was surfing on the internet and found this image. So if LB1 was a hobbit, it was a pretty sick hobbit. I rest my case.